Today's topic is the prisoner's dilemma. The prisoner's dilemma is used to explain one of the outcomes or consequences of game theory. What is the prisoner's dilemma? The prisoner's dilemma is used in game theory to explain the difficult situation a player, in a game, faces in deciding his best strategy. The players know that it is better to cooperate. If players in a game cooperate with each other, the outcome would be in the best interest of all of them. But there is always a problem. A player does not have adequate information about the other player's moves. Consequently, a player will adopt his own strategy because he is unsure of the other player's courses of action. The prisoner's dilemma shows why cooperation in an oligopolistic market produces the best outcomes for all the firms. An oligopoly is a market where there are few dominant firms. Why is it called the prisoner's dilemma? The name originates from a situation in which two people detained on suspicion of committing a crime decided to confess and get a longer prison sentence than they would receive if they had cooperated or remained silent. Let us consider an example. Jane and Jerry were caught at the scene of a crime. But they were not caught in the act. Therefore, the police have no evidence to present against them in the law court. This means that if they refuse to confess during interrogation, they will be acquitted by the court. They may only get a minimum jail term, maybe for illegal possession of goods or other minor offenses. But the prosecutors are worried because a crime has been committed, and it attracts a maximum of 12 years jail term. The government lawyers would explore many options to get the suspects to confess. But this will be difficult to achieve if the suspects are being questioned in the same room. The prosecutors explore another option, keeping them in different rooms and persuading them to confess. The prosecutors know that if the suspects are being interrogated together in the same room, they will cooperate and not confess. Therefore, the suspects are separated physically and interrogated separately. A deal is offered to each player, without the other player knowing. It is expected that the suspects will accept the deal, and confess because they cannot communicate with each other. The deal is that anyone who confesses will be freed while the other person who denies will get the maximum jail term of 12 years. Let's consider the options available to Jane and Jerry, the suspects. The following payoff matrix shows the outcomes, the jail terms, when the two suspects, Jane and Jerry, choose to confess or decide not to confess. In the payoff matrix, the first number in each cell, color blue, is the jail term for Jane, while the second number, color red, is the jail term for Jerry, if each decides to confess or not to confess. The actions taken by Jane are in the rows, while those of Jerry are in the columns. Each could receive a maximum sentence of 12 years if convicted. The prosecutors promise each suspect that by confessing, he or she will go free or get 0 jail term, while the other suspect who does not confess will receive the full 12-year sentence. However, they are kept separately and not allowed to communicate. If both confess, each gets a reduced term of 6 years imprisonment. Which option or strategy is better for Jane if Jerry confesses? To ascertain the strategy of Jane, we will consider the effects of the actions of the other suspect, Jerry, on her payoff or jail term. This determines the option that Jane will choose. So, let's start. If Jerry confesses, reading along column 3, Jane gets a jail term of 6 years if she also confesses. Remember, Jane's payoff is in blue. If Jerry confesses but Jane does not confess, Jane receives a 12-year sentence. Therefore, if Jerry confesses, it is better for Jane to also confess. Doing this will get her a lower term of 6 years imprisonment, compared to the 12 years she will receive if she does not confess. The strategy here is for Jane to confess if Jerry confesses. We want to determine Jane's strategy if Jerry decides not to confess. We will start with Jerry to ascertain the effect of his action on the payoff of Jane, as this determines the action Jane will take. If Jerry does not confess, reading along column 4, Jane will get a 0-year jail term if she confesses. However, if Jerry does not confess and Jane does not confess, Jane will get 1-year jail term. So, the option that Jane will choose, if Jerry decides not to confess, is the one with the lower jail term of 0 year, which is, confess. What is Jane's dominant strategy? A dominant strategy is the most favorable choice for a player, regardless of the actions of the other player. It is the best choice Jane can make, because she is unsure whether Jerry will confess or not. If Jerry confesses but she doesn't, she will get a maximum jail term of 12 years while Jerry will be released. She gets 6 years if Jerry confesses and she confesses. She gets a 0 jail term if Jerry does not confess but she confesses. The best strategy for her is to confess. She will end up getting a jail term of 6 years or 0 year. This is her dominant strategy. Let us try to find out whether Jerry has a dominant strategy, that is, the best option for him, whether Jane confesses or not. To determine the strategy of Jerry, we will consider the effects of the actions of the other suspect, Jane, on his jail term. If Jane confesses, reading along row 3, Jerry will get a 6-year jail term if he also confesses. Jerry's payoff is in red. If Jane confesses, but Jerry does not confess, Jerry gets a sentence of 12 years. Therefore, if Jane confesses, Jerry should also confess, because this will get him a lower jail term of 6 years compared to the 12 years he will receive, if he decides not to confess. The strategy of Jerry is to confess if Jane confesses. Let us examine Jerry's strategy if Jane decides not to confess. If Jane does not confess, reading along row 4, Jerry will be set free, that is, he receives 0 jail term, if he confesses. However, if Jane does not confess and Jerry does not confess, Jerry will get a prison term of 1 year. So, the strategy that Jerry will choose if Jane decides not to confess, is the one with the lower term of 0 year, which is to confess. What is the dominant strategy for Jerry? If Jane confesses, the best option for Jerry is to confess, since he gets a jail term of 6 years as against the 12 years he will receive, if he does not confess. The best option for Jerry is still to confess, if Jane does not confess. This will get him a jail term of 0 year as against the 1 year he will get for not confessing. In both situations, the best strategy for Jerry is to confess. That means Jerry has a dominant strategy, which is to confess, whether Jane confesses or not. In conclusion, suspects will choose to confess because they are not sure whether other suspects will confess or not. There is no way to communicate with other suspects, because they are not kept in the same room for questioning. Oligopolistic firms usually face a prisoner's dilemma problem in deciding on their pricing and advertising strategy, or on whether to cheat in a collusion. However, there is uncertainty about the actions of other firms. So, each firm will choose a dominant strategy. But they could do better, or make more profit, by cooperating or colluding.